Okay, we used the same 555 timer circuit from the module, except we replaced the resistor RB with a 100 kilo ohm potentiometer. We also have a capacitor here in order to reduce the amount of noise in our final oscilloscope reading. Potentiometer controls the amount of voltage that enters our trigger and threshold voltage nodes. As you can see, we are outputting a square wave. We're about to show you that by changing the resistance in RB, we're able to change our frequency for our final output voltage. Yeah, pretty much it.
Alright, this second subcircuit is our filtering subcircuit. So it takes in the input of the square wave from the 555 timer, and through a parallel circuit of both capacitors and resistors in parallel, we can now see that the output of the square wave has turned into a sine wave.
No way, I need to change the frequency again.
Yeah, the more capacitors and resistors we add in parallel, the more like a sine wave that the initial square wave input becomes.
This is the BJT, which clips the voltages on the bottom and low. This adjusts the voltage into the gate, which will then change the saturated or V on voltage. It'll clip it between the V on and the saturation voltage. If this goes above the thing.
We need to do
That's crazy.
just change it and get it done. It's fine. Like, see, the video
And this one changes how much this affects the change of voltage. So this basically changes the offset.
Here I'll be describing the functionality of our op-amp. We took the output from the BJT clipping portion of our lab and used it as the input of our buffer subcircuit created using the op-amp. This buffering subcircuit essentially allows the input voltage to equal the output voltage, as there's no additional current loads affecting the input due to the high input impedance of the op-amp, and thus allowing us to have a voltage gain of 1. Using this buffer output, we then use this as the input for our inverting amplifier. We use the potentiometer as our feedback resistor to allow for a variable voltage gain, and since the amplitude is based on the ratio of the feedback resistor and input resistor, by adjusting the potentiometer, we got the amplitude of the voltage to increase to the 10 volt to 12 volt ideal range.